Hey everyone, welcome back to another stream. I feel like I'm getting good at this now. I'm a bit more confident. For some reason, many a times I wipe out all of my streaming settings as soon as I stop streaming, and so it's always a bit of a pain to actually restart a stream. All right, so I guess I'm live now. Yeah. All right. So hello everyone, and welcome to the stream. I was saying that I was gonna upload more videos now. So far, so good. That's pretty cool. I really did wanna film more videos. Alright, so in the previous streams, we figured out how to build like a very simple projectile motion physics simulation kind of a thing. In this video, this stream, I think we are gonna try to build some kind of a language model using PyTorch. Uh, it's not going to be a large language model in any way. So if you're expecting this to be sort of like chat gpt or like gpt, you're going to be headed for disappointment, because we are not going to be doing any kind of fine tuning or anything like that on the model. This model will just be able to generate characters of Shakespeare. That's all I'm going to be doing. Maybe I might do some kind of fine tuning and we could maybe make it a bit better, but that is like a very big maybe, and there's like a 1% chance that that is gonna happen. It's definitely not gonna happen in this stream. Believe me, I'm probably not even gonna finish the whole thing in this stream, because I'm not really gonna go for as long as it takes. I'm gonna probably break it up in like 2 or 3 streams, because I really cannot stream for long. Mainly because I can't really sit down and just stare in front of a computer screen for very long. My eyes kind of start to hurt, so I'm not really gonna do that. So yeah, all right. So that's pretty much it for the intro. As I said, we're gonna be generating Shakespeare, but you're free to use any dataset that you want. I would recommend you keep the dataset size small unless, of course, you have more computational power available. I'll be using a Google Collaboratory for this. You can use anything you want. I would recommend you use a Google Collab. They are pretty good, and they work nice. So I'm gonna use this. All right. So okay. So basically, I kind of tried making this project of camera a while ago, like a couple of days, maybe a week or two ago. But I then decided to do it on stream. So yeah, I'm gonna get rid of pretty much all of this code. I'm trying to get good at PyTorch. I know it's pretty much writing the same code all over again, but I've forgotten like all of it. All right, let's just get started. First thing we need to do is I'm just gonna check a couple of things. Just check if we are running on a GPU, which we are. All right, and what else do I have to see? Yeah, first of all I need to connect, and once we connect I'll actually have to port my dataset into here. Also, for now I'm gonna change my color scheme to dark, since it's a bit more easier on the eyes. Alright, so now I'm just gonna uh, put all of the data that I have in here. So I'm using Carpathi's, shall I say, I don't know, I guess it was this text file. Yep. Basically, I'm using Andre Karpathy's Shakespeare thing. It's so yeah, just for attribution. You can just search up Shakespeare, text Shakespeare datasets. You'll find something like that on Kaggle or something. It's just going to be a text file. Go ahead and download that real quick. Alright, so let's just make the necessary import. So we're gonna need torch, from torch import nn, and pretty much we're gonna need these four pretty much. Other than that, what else will we need? Now that I think about it, not a lot more. So I'm just gonna run the code now. Okay, so now let's actually load the data in. So file equals open, okay, data file equals open, and I'm just gonna copy path. Oops, what is happening? Alright, I'm just gonna copy path, paste that, and we just wanna read it, so I'm just gonna put it in as R, and then we can just say data equals data file dot read, and that should give us the data. So obviously this entire thing will be stored in like a one long string kind of a thing, uh, pretty much. If you wanna check out, we can run some like basic things on the data. Like when I say run, I mean just get some basic information regarding the data. So we can just say like len of data, just get a brief idea of how long the string is. I'm gonna put all of this in a print statement, and we can also print out. Yeah, I mean I could print out the first 100 characters, but I'm not really gonna do that. If I just say print the set, actually no, list of set of data, that should give me the list of characters, unique characters that are there in the data set. So these are all of the unique characters that there are. So starting from all of this, there's also going to be the space character, and there are a couple of the, so basically it's our new line character. So finally there's a dollar sign somewhere. So the particular reason as to why I asked you guys to choose this particular data set is because since this is a play, it pretty much just uses the 26 letters of the alphabet, and it does use a couple of other letters also, but really the major letters that are being used are the letters of the alphabet. Now, a couple of things that you could potentially do is you could maybe put all of these letters in lowercase in order to reduce the number of tokens that there are. However, that's really not gonna be something we care about. The reason why that's the case is because the way we're gonna be tokenizing our data is a bit different. Actually, basically, I'm pretty sure the way you have probably seen tokenization up till now is that we tokenize every single letter of the thing, and then we just construct a word using the per letter tokens. In such a case, it would make a lot of sense for us to actually reduce the number of tokens and then construct our new tokenized dataset using those reduced number of tokens instead of having the original number of like much larger number of tokens. And while that is a good idea, the thing is we are not going to be using a character level tokenization method. We are going to be using a subword kind of a tokenization method. Now, particularly the method we're going to be using is what was used by GPT. So yeah, that's kind of what we're going to be going with. And instead of actually obviously coding the whole thing out, they actually have a library to basically get those encodings and do everything for us. So we can just use that library. So it's on OpenAI's GitHub only, you'll find it, tick token. So this is what they use. So yeah, here are all of the stats and stuff. I mean, I don't really care. So they use what is known as byte pair encoding. Yeah, so pretty much what byte pair encoding is, pretty much it's just tokenization. Alright, so we first obviously need to install tick token. So I'm gonna go ahead and do that in the first code block. We'll do all of our installations up there. So I'll just do pip3 install tick token. We'll just run that. It should take a second or two to run. And alright, I'll just finish that up real quick. Okay, successfully installed. Perfect. Okay, I'm just gonna close this, and now I'm just gonna go ahead and import tick token over here, and we're gonna run this again. Hopefully it doesn't throw us any errors. Alright, it doesn't throw me any error. That's perfect. Alright, so now we actually need to tokenize our dataset, which is a very easy thing. We first get an encoding, and then we pretty much just run enc.encode on whatever string it is that we want to run it. If we want to decode that string, we simply run enc.decode. So we'll just go ahead and copy that. Actually, nah, we'll use this example. So we'll use this example. So we simply get an encoding. So we'll simply copy that and we'll paste that in here. And then we can just say tokenized data equals enc dot encode data, and that's perfect. So obviously now your data is going to be a list, it's not going to be a string any longer. Actually I guess that's the case, I'm not too sure. Again, let's just run type on tokenized data so we get a better idea of what it is that we are expecting. Okay, I didn't spell that correctly as always. Okay, copy that, paste that in there, run that. Okay, alright, it is a list. Let's get a better understanding of what the list even looks like. So we'll say tokenized data, let's get the first 100 tokens. Alright, so as you can see, this is how the list is. Pretty cool. Awesome. So now we have a good understanding of what the thing looks like. So now we actually can get to constructing our X train and Y train for our for our model. Now see, that's where, so this was once place that I usually used to get stuck, like I wouldn't really know how we kind of said that. But after watching a few videos, after reading a couple articles, reading a couple of books, I've actually kind of started to understand this part. So I might take a while on this. I just hope I don't, because I really don't really like to deal with this part, to be honest. I kind of just want to get started with like the model training and stuff. All right, so basically the thing is, the first kind of, I would say, goal is not to build like a very super powerful model or anything. We are not planning to build a transformer right now. Probably in the second or third stream I'll start with a transformer and we'll see how it goes. If it goes well, we'll actually make it. Otherwise, well, at least we'll have some model to show. So yeah, and since we're building a basic model right now, I mean, one good thing is I don't really need to worry about a lot of stuff, like shapes and all, because I mean, in a simple model, all of that stuff is relatively straightforward. So that's one good thing. I should probably have some kind of a method to maybe alter that stuff a bit easier later on, but I'm not really gonna care about that. Alright, so now let's actually get started with the X trains and the Y trains. So what should the X train look like? So if we look at X train, what should it look like? So if the X train is something like coding made, basically what we want to do is, let's look at it like this. The target is that if I give my network the words coding made, then it can kind of predict easy or something like that. So if I say something like, so if my target is something like this, and I'm building this out character level, we are not really doing that, but still. So what should my X train look like? Well, in that case, my X train could be looking obviously like this. And in that case, since I'm trying to predict the Y train will look like something like this. So basically every letter in X train is kind of, the Y train is predicting every successive letter of the X train. So the O predicts the C, then D after the O, something like that. I hope you understand what's going on over here. So that's kind of what is happening, and we're going to be using that method to generate our X train and Y train. So alright, so first we obviously need to set a sequence length, because we need to understand exactly where we are splitting this word, right? So we'll just set a sequence length, and I'll set it to 10 for now. Usually I guess it's a bit longer than this, however frankly I'm not very sure. So we have the sequence length. So now let's just get a feel of what X train and Y train might look like. So if I just use tokenized data, well then X train effectively looks like, well, I'm going from 0 to 9. So I'm going from 0 to sequence length, and so that's what X train kind of looks like. Y train on the other hand will look like, so not like that, but it should kind of look like 1 to sequence length plus 1. So one thing I can see is that this should start from an index I and go on till I plus sequence length, because right now it's starting at 0 and it's going from 0 to 0 plus sequence length, which is sequence length, and this starts from I and then goes on till sequence length plus I, something like that. So we can use that method, that property, whatever you want to call it. So I'm gonna go ahead and make two lists: X train, Y train, for I in range, len tokenized data. Alright, wow, they actually figured this out. That's kind of funny. I figured this was a cool thing that I figured out right now. Kind of sucks, bro. I thought the AI wouldn't be able to figure this out. Alright, cool. Okay, so basically this is what we're doing, and I think this is actually good enough. So now we can convert the X chain and Y chain into tensors. So X chain, damn. So let's just, alright. Yep, I have a tiny mistake. Alright, there we go. Now if I get, alright, there we go. So we have X chain and Y chain shapes, which is exactly what we want. Alright, now we can actually get started building the model. So class simple MLP and then dot module. Alright, I'm gonna utilize the code that I wrote for my auto encoder over here, so we can just use that real quick. Alright, so this is the thing, and yeah, so here you can see this is how we make the network. Alright, so I'm pretty much just gonna copy this. Alright, so now we can make the network. Let's start with something simple. So it's obviously going to be inputting X train. So the okay, so let's actually write this. So self dot h1 equals, and then dot linear 10, and let's just say, okay, you know what, let's go with 200. Alright, but what should be the output layer looking like? You know what, first let's actually add activations to this. let's just ask Gemini. And I'm guessing we need softmax for this. Tan H. Why tan H? Let's work with softmax for now. Alright. There we go. So now we can make the forward pass really quick. I'm pretty sure Gemini will just generate it for us, so that's one good thing. There we go. Do we have to return X? Yep. There we go. And that's pretty much it. Let's run that. Alright, so we can just call this model equals M. Let's call it model 1. MLP. And yeah, that's pretty much it. So I mean, we'll obviously use these two things. There we go. Alright, perfect. Perfect, we didn't get any errors. The optimizer line had caused me like a lot of grief the last time. And hey, it's good that it worked this time, because otherwise that would have sucked. Alright, so now... Okay, now here's the deal. We have X chain and Y chain, which is pretty neat and all. But one problem with X chain is that it is not batched. And trying to feed all of this in to the neural network at once, I don't think that's smart. I just don't. So we need to batch X chain and Y chain. So how do we do? So batch a PyTorch tensor. Oh, you know what? I'm gonna do a chat GPT on this. I usually don't like to use chat GPT for coding, but I think I need to fire this. Batch what probably not the best prompt, but still, let's see if it can. Yeah, give me the code. Nah, this isn't what I want. I don't want this. Stop. Alright, how to create in probably not the best prompt again, but still. Oh, come on, give me the code. Damn, that's a. I mean, I get it that it's pretty much this code, but still. Maybe I can just use the data loader. I guess that's the most practical method. Yeah, I'm gonna use a data loader. Alright, that's pretty much what I'm gonna do. uh, Again, not the best Google search. Okay, so we do that and then we can batch. Nice, perfect, exactly what I want. Alright, cool. So I'll pretty much do it right over here. Paste that in there and there we go. Yeah, batch size 32, I guess it's good. I don't think I need to shuffle. I'll run this and we should be good. Good to go. And we get an error. I need to import that. That sucks. Alright. Yeah, so you know what? I'm using it for one line, so I'm not gonna make that entire import statement. Do that. Cool. So now we have a data loader, and we can pretty much use that data loader when we are making the training loop, which is pretty cool. Alright, so now we can start with the training loop. So again, I'm going to be using this training loop as a reference. And as a reference, I mean, I'm pretty much going to be copying most of it. But yeah. Again, let's set epochs, couple of your parameters that you need. Oops. Why am I not able to type this? Alright, so for I. Yep. Damn, this literally did everything for me. Alright, I also want to print out like. Okay, I want to have a running loss, so we're gonna make that variable and we're gonna keep a running loss. I'm gonna put that in here and okay, then we can just update the running loss right there. Do that and do that. Then here we can just print out. So basically after every epoch we print out the running loss. Let's see. And we got an error. Matrix 1 and matrix 2 must have the same data type but got long and float. What do you mean? Alright, I know I need to typecast something, so, or like basically convert the data type on one of them, but which one? I'm not sure. And also, like, I'm not sure about the matrices that they're talking about over here right now. Like, do they mean to say I need to change the data types of the model weights and the inputs, or like within the inputs the X train and the Y train? So let's take a look. Matrix 1, matrix 2 must have the same data type. Alright, so let's just set a data type in here. It's such a stupid error that I just made over here. But when did I? These kinds of errors are the worst. They are literally very hard to spot. Alright, so that should potentially mitigate this issue, although I'm not very sure. Still doesn't do anything. Explain error. I'm way too dependent on AI right now. Alright, let's take a look. I mean, didn't I just do that? Alright, you know what? We'll do whatever you have to. Who cares? Found data type long but expected flow. Explain error. I mean, I know I need to probably change y preds data type, something like that. I've never seen such errors in TensorFlow. Alright. Yeah, what I guessed. I need to convert this to a floating point. There we go. Alright, let's let this run. It's currently running on the CPU since we haven't transferred anything to the GPU. But still, let's take a look. It's taking quite some time. Alright, we got that. I mean, I can see there is optimization taking place. I'm not sure what the running loss over here means because it's very off. Wait a minute, what is the loss that I'm using? Mean squared error. Why am I using mean squared error? I shouldn't be using mean squared error. I guess what I need is what do I need? Which loss function should I use? Alright, so I have made a programs like this similar in TensorFlow, so I'm gonna use that as a reference for the hyperparameters. Alright, so I'm just gonna quickly use that. Where is it? I made like an Eminem song generator. Why does this have to be an I find B? I know I have a Shakespeare thing also, so I'm gonna use that. Yep. Alright, there we go. And softmax. Oh, okay, so we are passing in max ID over here. That's another thing. Alright. Okay, you know what? One thing at a time. First off, I wanna check out the loss. So we are using sparse categorical cross section. How on earth is this running if the loss itself is incorrect? PyTorch sparse categorical. One thing I can say is that I think TensorFlow docs are better for uh, learning TensorFlow, because I checked out PyTorch docs and they are, I don't like them as much. And you have to depend on the forum and everything a lot more. Uh, okay, where is. Wow, does PyTorch really not have anything? Bro, that is not. Is there sparse categorical cross entropy in PyTorch? So I mean they're using cross entropy. Now I know for a fact that now I know that cross entropy and sparse categorical cross entropy are different losses as far as I know. And I mean this is a relatively new question, even it was modified relatively like somewhat right now. So it does it not have like, do we have to actually code sparse categorical cross entropy out by ourselves? I guess I'm gonna have to do that. Either that or I'm gonna have to do something else like along those lines. Another problem that I just realized is that basically in the model that we were building, like that I built initially, was that the way I was actually generating these labels is that the output layer, it had a max ID number of neurons, and max ID was basically the number of unique tokens. Now the problem with that is that uh, the number of tokenized tokens is very large. We can't actually have those many over here in the output layer. So in that case, or maybe we do, who knows. Okay, so I'll check that out in like the next stream, but for now I mean I'm pretty much gonna end it here, because I mean there's a lot remaining and I frankly wanna approach it with like a fresher mind. For now I mean we did get quite a lot of work done, uh, but yeah, we'll finish that last bit of work later on and potentially make a better model, because right now it's pretty bad. I also don't know like if PyTorch has like LSTM, GRU, that kind of stuff. I'm pretty sure it has GRU. I'm not sure about LSTM and RNN blocks. So yeah, we'll check all of that out in the next video, and hopefully through this I get to learn more about like PyTorch text generation and text classification. So yeah, that's pretty much it for this video. I hope you enjoyed it, and stay tuned for more streams like this, and I'll see you in the next one. Until then, I mean we had a pretty short stream, 40 minutes, but I mean I guess that's pretty much it for this one, because I wasn't intending to stream for long this time. I just wanted like a short and good stream, and I mean we did get a decent amount of work done, and so I'm pretty happy with what we kind of had, what we have done. So yeah, that's it for this video. I hope you enjoyed it. If you did, like and subscribe to the channel as always, and I'll see you again.